All right, everyone, we're going to start our next unit in our chemistry course, which is our solutions and solubility unit. So you just finished doing some stoichiometry, which don't forget about it because it's going to come back later in the unit. But as this first chapter, we're going to take a little bit of a break from our math and focus a little bit more on terminology. So chapter 8 starts off with classifying solutions. So let's dive in. So what are we talking about today? We're going to have an introduction into the topic. We're going to talk about different types of solutions, and we're also going to talk about saturation. Now, some of these words should be familiar to us. Maybe we've talked about them in science before, maybe everyday life. But if we're not familiar, no worries, we will be by the end of today, for sure. So we have 3 learning goals for the lesson today. First one is going to describe a solution and its various components. Then we're going to be able to identify different types of solutions. And then we are going to be able to explain solubility and saturation. Here we go. So let's start. So solutions. First thing we need to know is what is a solution? And a solution is a homogeneous mixture of 2 or more substances. So you could have 3, you could have 5, you could have 7, you could have 100. You just can't have one. You need to have at least 2 substances that are the same because a solution has a homogeneous composition, which means it is the same throughout. No matter what happens, it is the same throughout. And all samples of a given solution, no matter how small, contain the same substances in the same proportion. So if I made a solution of sodium chloride and I decided to split it up into a 2-liter container, a 1-liter container, an 100 ml container, and a 25 milliliter container, it is entirely the same. Just because I split it up from the original container doesn't mean any of the composition changed. All of the sodium and chloride ions are present in the same proportion regardless of the container. Moving on, we're going to talk about the different parts that come together to make a solution. So the first would be the solvent, and this is the component of a solution that is present in the greatest amount, which means that we have a solute, and that is the substance that is dissolved into the solvent. Okay, so we have solvent is the first one, and solute. The solute goes into the solvent. Now, if we want to get specific, a solution that contains water is known as an aqueous solution. And this could be familiar to you from when you were doing stoichiometry and you were writing reactions. And it wasn't a solid, it wasn't a liquid, it wasn't a gas. It had that AQ next to it, meaning it's an aqueous solution. And these solutions can be colored or colorless, it doesn't matter, but they are always transparent. So they're never going to be opaque. You're going to be able to lift up your beaker, look through, and be able to see, regardless of the color or if it's colorless. Good. So now we have different types of solutions. So a solution can be formed from a solvent and a solute, like we talked about on the last slide, in any state. So states of matter we know are gas, liquid, and solid. So that's right. Typically with solutions, we think, oh, it's a liquid. It's always a liquid into another liquid, or maybe a solid into another liquid. But that's not the case, which means there are 9 different types of solutions that are possible. So these next slides, we're going to look at examples of the different types of solutions. Now, you don't have to copy them down. They are just examples, but if you choose to, I suggest making a chart that has solid liquid gas across the top and solid liquid gas down the bottom, and then you can just fill in the remaining points as I go through the slides. So here we go. So first we're going to look at solids dissolved into blank. So our first example here is a solid dissolved into another solid, which we don't often think about, but it does exist. So our example here is structural steel. Then we have our solid dissolved in a liquid, which is seawater, which makes sense because we know that if we go to the ocean, it's going to be very salty. And then our solid dissolved in a gas. This example is a little bit out there and hard to conceptualize, but it's there, I promise. And it's naphthalene, and these are basically just the little mothballs. Now we have our liquid types of solutions. So our first one is a liquid dissolved in a solid, and our example for that is finishing wax. Stuff you put on your furniture. If you have grandparents or parents that make stuff out of wood, you could put some finishing wax on there. And then we have our liquid dissolved in a liquid. It's getting cold outside. Make sure you have this in your car, or tell your parents to make sure they have this in their car, and that's antifreeze. Okay, so that's a liquid solute dissolved into a liquid solvent. And then we have our liquid dissolved in a gas. Couldn't really find a picture of this because the example is humidity. So this is a hygrometer, which measures the level of humidity. So the actual meter itself is not the solution we're talking about. The solution we are talking about is humidity, and that is a liquid dissolved into a gas. Next, we have our gases. So first we have a gas dissolved into a solid, which is ice. We all know that. Next is a gas dissolved into a liquid, which is pop. And again, I think that one's pretty common too. And lastly, gas dissolved in a gas would be, an example is natural gas. So at my house, I still have a natural gas stove, which looks like the picture. So my solution there is a gas dissolved into a gas. Okay, so 9 different types of solutions involving states of matter. They can all be dissolved into each other. Now let's take a step ahead and we're going to start describing solubility. So solubility is the maximum amount of solute that will dissolve in a given quantity of solvent at a specific temperature. Okay, which means just because your solubility is something at 20 degrees Celsius does not mean it's going to be the same for a different solution at 30 degrees Celsius. All right, and usually the units are grams per 100 milliliters. So here we have a table. So a solute can be described as soluble if more than 1 gram will dissolve in 100 milliliters of solvent. A great example of this is table salt into water. Okay, we know that if we put some of that in, we mix it up, it's going to dissolve no problem. Well, a solute can also be described as slightly soluble, which means between 0.1 grams and 1 gram will dissolve in 100 milliliters of solution. So an example of this is calcium hydroxide. If you have the right amount, it is soluble. Too much won't dissolve. And then lastly, a solute can be described as insoluble. So that's if less than 0.1 grams will dissolve in 100 milliliters of solvent. An example of this is chalk is insoluble of water. Now, I don't know if you have chalk at your house, but if you do have it lying around, crunch it up, throw it into your water, keep stirring it around, and let me know what happens. My guess is it's probably not going to dissolve. All right, now last thing we're going to talk about is solubility and saturation. So when I like to talk about saturation, I like to think of Kool-Aid. Okay, so keep that in your mind as we work through this slide. So first we have a saturated solution, and that's when a solution cannot dissolve any more solute. So I like to think of this as the perfect cup of Kool-Aid. I put the exact right amount of Kool-Aid powder into the water. I dissolved it, every single piece dissolved, and my cup of Kool-Aid is fantastic. But now I have an unsaturated solution, and that's a solution that could dissolve more solute if we added it in. So this is your cup of Kool-Aid where I'm going to say red because I like the red Kool-Aid. If I put just a little bit of Kool-Aid powder and had a lot more water and I mixed it up and it wasn't that nice red color and it was more on the lighter side and almost a little bit transparent, that's an unsaturated solution. And now we have a supersaturated solution. So we've gone from the middle, which is saturated, unsaturated on one end, supersaturated is the other end. And that's when your solution contains more dissolved solute than a saturated solution at the same temperature. That's important because remember we talked about solubility changes based on temperature. Okay, so an example of this is many saturated solutions dissolved in water become supersaturated when they're cooled down, and then this leads to a precipitate. So if we know that if it's supersaturated, there's got to be way more solute in the solvent. So yeah, you could stir it up, but then once it cools, all of that extra solute that makes it supersaturated is going to come out in a precipitate in our solution. And that's all we have for today. Hope you enjoyed this lesson. Thanks for watching.